Hello everyone, my name is Elena and welcome to the MathLive.com channel. In this video we will be determining the intersection points from three different lines on a triangle. An example is given below of a triangle that's formed of three different lines that connect at points A, B, and C. Now it's important to note that as long as two lines are not directly parallel to each other, there will always be one intersection point between those lines. In this problem, it's given that the intersection points are A, B, and C. If we were to look at one of those points, let's say A, we can see that this is where the lines 1 and lines 2 interact. By eyeballing this point A, we can see that lines 1 and 2 share the same x value and the same y value. By sharing the same x and y value, we know that that means that this is a coordinate that both lines have in common in their functions, and therefore it's an intersection point. And furthermore, since we know that they have the same x and y value, we can set these lines equal to each other in order to find where that exact coordinate is. So step 1 of finding the three intersection points is to first determine one point that you would like to find first. In this example, we are starting with point A. As I mentioned previously, since these points share the same x and y value at this point A, we can set y1 equal to y2 and determine which exact x and y values this intersection takes place at. So if we have two lines, one of them being y1 equals x plus 5 and y2 equals 3 over 8x, we can set x plus 5 equal to 3 over 8x and solve for x. Once we do the algebra, we can see that x is equal to -8 at this intersection point. Since the lines are equal to each other at point A, we can substitute x equals 8 into either line 1 or line 2 to determine their y value, since we know that both values will be the same. So if we substitute x equals -8 into y1, we can see that -8 plus 5 is equal to -3. If we substitute x equals -8 back into y2, we can see that y2 is equal to -24 over 8, which is equal to -3 as well. So no matter what line you plug x equals -8 into, you will yield the same result for your y value, as these points share the same x and y value at this point A. So once we've determined the x and y values for this intersection point, we can see that the coordinate of point A is equal to -8, -3. Now that we've solved for point A, we are going to use the intersection of lines y1 and y3 to solve for point B, as we can see this is where they share the same point. Following the same steps as we did with point A, since we know that at the intersection of y1 and y3 they share the same x and y value, we can set y1 equal to y3 to determine what exactly those values are. So by setting them equal to each other, we get x plus 5 is equal to -x plus 11 over 2. When you combine like terms, we get that 2x is equal to 11 over 2 minus 5, or 2x is equal to 1 over 2. We can simply plug that into either y1 equals x plus 5 or y3 equals -x plus 11 over 2 to solve for the y point. It doesn't matter which equation you plug it into, because both of them share the same y value. If we were to plug it into y1, we get that 1 over 4 plus 5 is equal to 21 over 4. If we plug it into y3, we get that -1 over 4 plus 11 over 2 is equal to 21 over 4 as well. Since both y values are equal to 21 over 4, we can conclude that the coordinates of point B are 1 over 4, 21 over 4. So now that we've obtained the coordinates for point A and point B, all that's left is to find the coordinates of point C, which is described as the intersection between line 2 and line 3. Just as we did previously, since we know that y2 must equal y3 at that intersection point in order for their coordinates to be the same, we can set 3 over 8x equal to -x plus 11 over 2. Once we combine like terms, we see that x is equal to 11 over 2 times 8 over 11, which is equal to 8 over 2, which is equal to 4. So x equals 4. Knowing that x equals 4, we can plug that into y2 or y3 to get our coordinate for y. If we plug it into y2, we get that y is equal to 3 over 8 times 4, which is equal to 3 over 2. Or if we plug it into y3, we can get that negative 4 plus 11 over 2 is also equal to 3 over 2. Since both points are equal to each other, we know that C has the coordinates of 4, 3 over 2. We will now use MathLive.com to see a graphical representation of the three lines that formed the three intersection points that we calculated by hand. If you enjoyed videos like these, please make sure to hit the like and subscribe button to see more content such as this. By looking at the left side of the screen, I have already inputted the functions for the three different lines that we were solving for. We can click this Show Intersection Points button in order to see what the solutions look like at each point. From there, we can use the zoom feature to zoom in on any point we'd like to see a closer look of what their intersection was. For point A, it shows us that the intersection is negative 8, negative 3, which is equal to the point that we obtained when we solved it by hand. We can use this home button to rescale our axes to the original image and zoom in on the intersection of point B. At that intersection, it shows that the point is 0.25, 5.25, which is equivalent to the 1/4 21 over 4 point that we obtained by hand. Finally, if we zoom in over point C, it shows us that the intersection is at 4, 1.5, which is equivalent to the 4, 3 over 2 value that we obtained by hand. Since MathLive shows us that their intersection points of the three lines were equal to the intersection points that we obtained, we can conclude that our values were correct. Thank you for watching, and make sure to check out the MathLive.com socials and the MathLive.com website for more help with your math problems. Thank you.